To find the summation of a series given just the numbers and not the sigma notation, the easiest way to usually do it is to figure out a general formula for a sub n. Okay, we know that our first term is 5, so I'm going to use my 5 as my a sub n first. And I'm going to say that 5 equals, I know that I'm adding 3 each time. And I know that's my first term. Okay, so my 3 is going to be my starting term, or my leading term. My I is going to be my 1 because I know that's my very first term. So this is I equals 5 is I equals 1, 8 is I equal 2, 11 is I equal 3, and so on. So I know that k has to equal 2. So let's double check our formula. If I plug in a 2 into this formula, so my formula that I'm getting here is a sub n equals 3i plus, and then 2 for my k. So let's try that. If I plug in a 2, I get 6 plus 2, which gives us 8. If I plug in a 3, I get 9 plus 2, which is 11. So that is our correct formula. So the easiest way to do that, start with your first term. Since it's my first term, I know that my I is 1. I always multiply it by my growth, which is 3 every time. So I get 3 times my I plus k. I solve it, k equals 2, so I can go ahead and put that in there. So I get a sub n equals 3i plus 2. So if I look at my formula, my summation formula, we don't know our n value yet. We don't know how many terms we have. So to do that, we know that our last term is 92. So we're going to plug in a 92 equals 3i plus 2. Okay, we're going to subtract 2 from both sides. So I get 90 equals 3i, and I equals 30. Okay, that tells me that my last term of my sequence, or my n, is going to be 30. So I can use 30 as my n in my formula. And I'm just using the arithmetic series summation above. I know that my first term was 5. I'm going to add on my last term, which is 92. I'm going to take that whole thing and divide by 2. So I get 30 times 97 divided by 2. And when I do that, 30 times 97 is, oh, messed up on my calculator here. So I get 30 times 97, which gives us 2,910. I'm going to divide that by 2. So my total is 1,455.